All right, good morning, Springfield AWS users. As you know, tonight's meetup was canceled, so I thought I'd put together a quick video for everyone to take a look at if they were interested in AWS backup best practices. Add a comment to the video if you are hearing this part, because I intend to clip it off after a week or so. But I'll go ahead and cover general group info for any newcomers. So if you're new to Springfield AWS, please join us on Meetup, YouTube, Slack, or connect with other relevant events on the Springfield Tech Calendar. I'll run through those real quick. Of course, with Meetup, you can find us at /SGF-AWS. YouTube, our channel is SGF AWS. Please subscribe. I'd love to have you follow us. Slack, we have an active channel in the Springfield Devs Slack group, #AWS. Would love to see you join us there. You can go out to sgfwebdevs.com/slack to hit the invite page. And finally, if you're wanting to get involved in other tech events in Springfield, check out the Springfield Tech Calendar at /Springfield, fwdsgf.com. And with that, let's dive in. So tonight we were going to cover AWS backup best practices for EC2 and RDS, and comment on backup options for S3 if we had time. Obviously not in a time crunch today since I'm recording from home. A little bit about me. My name's Jason Klein. I've overseen AWS infrastructure for several environments, including a shared hosting company and a software as a service reporting platform. If you have any questions about the content, you're welcome to ping me in Slack, or if you're not part of our Slack group, you can always ping me on Twitter at JasonK, or you can pull up slides for this talk or contact me through my website at jrklein.com/talks. So first and foremost, before we dig into backup options, I wanted to talk a little bit about whether or not we need to back up on AWS. Obviously, their platform is designed for high availability and high redundancy, but that doesn't necessarily protect your data from major catastrophes, whether that be user errors, somebody accidentally deletes or overwrites a file, system errors, maybe an entire region goes offline. It's very, very rare, but you'd like to get back up and running, so be thinking about keeping your data in multiple regions at a minimum, or even security incidents. Someone comes in and takes over your server, and at that point, even if the data is there, the best practice is generally to rebuild that server and restore the data, so you know that you don't have any hidden problems that you're going to have to deal with later. But with that being said, if your servers don't contain data, focus on backing up your configuration instead. This is especially relevant for anyone who is already scaling up and down. You're not going to have a backup of every single server. You've got some sort of prototype, either an AMI, Amazon Machine Image, or a Docker image, or something along those lines that gets built and launched anytime you roll out new code, and then anytime you're scaling up. And so with that being said, you're more interested in making sure you have backups of your code, backups of your configuration that you use to build those images. So if you are using something like CloudFormation, make sure that you have backups of those CloudFormation templates, so on and so forth. But at least for our companies, we have a mix. More and more of our servers are not being backed up. We focus on backing up the data that's out in RDS, so your database, your relational data, and then data that's out in object store, such as Amazon S3. So we're going to talk a little bit more about that, but let's start by talking about EC2 for folks that do have servers that contain end user data or persistent data that need to be backed up. So when we talk about servers, we're talking specifically about EC2 instances or Linux virtual servers that store their data in EBS volumes. This isn't going to be as relevant if you're using empirical storage, or essentially storage in the local physical host, because you can't perform EBS snapshots on that local data. But fewer and fewer people are doing that these days. That the data in your EBS volumes is designed to be very reliable on Amazon infrastructure, but again, if you run into any problems with user error or security issues or what have you, you need to have backups of volumes that contain persistent user data. The best practice, of course, would be to move away from that. I mean, the more your servers can be stateless, the easier management can be, but not everyone's to that point yet. So when you're backing up the EBS volumes, you have a couple different options. Of course, if you're getting ready to perform a major upgrade, or you're doing something that could potentially impact your data, you could take a manual snapshot. As from our experience, as soon as that snapshot has kicked off and the console acknowledges that the snapshot is in progress, you're safe to go ahead and make your changes. You don't have to wait until the snapshot has completed, which is a great tip for folks who maybe have larger volumes and find that snapshotting can take minutes, many minutes. You can also automate your snapshots. A couple different ways to do that. In the past, before AWS Backup came around, we would script those snapshots. So we would run some sort of agent or script on each individual EC2 instance, and then that would kick off a snapshot from within the instance. Advantages of that are that we could run custom scripts that could freeze a database, freeze a file system, start the snapshot, unfreeze the file system as soon as we receive confirmation the snapshot's begun, and then unfreeze the database. And so we'll talk a little bit more about that in a second. But ultimately, we've moved all of our servers over to AWS Backup, which is a newer product that manages the life cycle of your snapshotting, not only for EBS volumes, but also for EFS, RDS, DynamoDB, several others. We're going to dig into that in a bit. But know that those are two options for backing up your entire EBS volume. AWS also offers the ability for you to open those snapshots and restore or recover individual files now. So it's not a matter of restoring the entire snapshot like it used to be. Other options, of course, if you're running Linux and you're coming from another environment, you may be familiar with a variety of either homebrew tools or open source or commercial tools. Long ago we would use rsync to back up all of our servers to an offsite system. Later on, we'd move to RDS Backups. So if that's not something you're familiar with, definitely check it out. It's basically rsync with incremental support. So your remote server can contain increments of your rsyncs, and you can restore from any of those increments, which has worked out really well for us. I'm not going to go into the various open source and commercial software. Just know that there are a lot of different options out there. We're going to focus mostly on the native AWS options today. So let's walk through a couple different views of the console. First off, if you're logged into the console and you go into EC2, you can scroll down on the left-hand side to Elastic Block Storage or your EBS section and view volume snapshots and so forth. This is a view of the volumes page where you can see a handful of the volumes in this particular account. They range in size from 8 gig to 300 gig. Nothing in particular that I wanted to point out here other than just showing the page for people who might not be familiar with it. If you go down to the snapshot page, you can see many snapshots for those volumes that we just looked at, again ranging from 8 gigabyte to 300 gigabyte. The description, you can't quite see it because it's not expanded, but it basically says this snapshot was created by AWS Backup. And you can tell by looking at the timing on these snapshots that they just continue to trickle in. I went ahead and prepped this a couple days ago, so even though it's the 5th, that snapshotting was current as of the 3rd when I put this together. If you are, we'll talk a little bit more about AWS Backup in a moment. Again, the benefit of it is that it manages the snapshots from beginning to end. But if you're not using that and you are using snapshots, be aware that the Elastic Block Store tools include a lifecycle manager that you can use to essentially purge your snapshots or delete your snapshots after a given amount of time. This is probably a good practice if you find yourself manually managing your snapshots, either manually taking snapshots or using custom scripts to take snapshots to ensure that they don't stick around forever. Now, with that being said, for servers that don't have a lot of data changing on the EBS volume, you could have snapshots stick around for a long time, and you're not going to incur a ton of costs. Given a specific example, we have that 300 gigabyte volume sitting out there in this particular account. That doesn't necessarily mean that we're paying for a 300 gigabyte snapshot every single day that snapshot is taken. AWS will certainly store the 300 gigabyte the first time around if the volume is full, but if the volume has empty blocks, they will only back up the used blocks in that volume. So that particular volume is pretty active. I wouldn't be surprised if all of the blocks have been used at some point in time, even though we're not using the full 300 gigabyte inside our server. But if you had just launched a server, you set it up with a 300 gigabyte volume, but you'd really only seeded the server with maybe 50 gigabyte of data, I would expect your initial snapshot to be 50 gigabyte. And then they'll perform incremental snapshots after that. So if you're seeing a data churn of maybe 1 gigabyte per day, so you still have 50 gigabyte the next day, but a gigabyte of that data has been touched, they'll take an incremental snapshot and you'll be billed for approximately an extra gigabyte. So good info to have if you're not familiar with the behind the scenes of the EBS snapshotting. With the number of snapshots that we have, we definitely looked into that to make sure we understood what that pricing was going to look like. When we'll touch more on pricing here in a moment. But before we do, let's look again. Let's go back to the volumes, and I drilled down to this specific volume. This is just one of the 8 gigabyte volumes, but notice the tagging on this. I mean, we have some common tags here. You can see the name tag that also shows up in the name column of our list view, a stack tag that we use to sort of manage these and make sure that anything that's not production is expired or removed in a reasonable amount of time. But the important one here is the backup plan tag, and I'm only going to show this in this one slide, but this is how AWS Backup knows to manage snapshots for this volume. And as we go into that product and look at how it's set up, you'll notice that we can set up different backup plans. This particular volume is protected by a backup plan that we named Daily Backup Plan. Pretty self-explanatory. It's backed up daily, but the beauty of that plan is that it will snapshot daily, and then we can specify after however many days to go ahead and expire that snapshot, and it can also manage sort of daily, weekly, and monthly intervals. So this particular plan, if I go to look at the history of snapshots for this volume, I'll see that it has about 7 to 10 days of daily snapshots, and then 6 to 8 weeks of weekly snapshots, and then either a year or so or an indefinite number of monthly snapshots. So even though these are incremental snapshots, the value of having the older snapshots around diminishes quite a bit for us. So, I mean, there's not much difference for us in going back to a snapshot 2 weeks ago versus 3 weeks ago. So why keep daily snapshots going back indefinitely? It cleans up the list of snapshots and makes it a little bit more manageable, and certainly can keep costs down if you have high churn data volumes. But let's dig into AWS Backup. Again, it'd be my recommended way of handling EBS snapshots. There are some caveats to that we'll talk about, but you can see an overview page here showing that for this particular account, AWS Backup had completed 16 backups in the past 24 hours. That would equate to essentially 16 snapshots. We're only using AWS Backup in this particular account with EBS volumes. If we go into the list of backup jobs under AWS Backup, you can browse through and you can see information for each individual job. You can also go back to EC2 and look in your snapshots and manage the snapshots directly under the EC2 console. This gives you a little bit of time, a little bit of information about snapshot scheduling, so when it occurred, when it was completed, so on and so forth. If you drill down into a snapshot, you can see a little bit more detail. Honestly, for us, we haven't had a huge use for this because we haven't had any snapshots fail. So this has really run on autopilot for the past year or so, because we adopted this in February of last year, almost exactly 12 months ago. Now, if you go in and manage your plans, you'll see the daily backup plan that I was referring to. The plan itself is named a daily backup plan to tell us that the volume that we're attaching that tag to is getting backed up daily. But if you look at the backup rules, you'll see how we have rules that mention daily backups, weekly backups, and monthly backups. And if you drill into each of those rules, you can set timing and such. And AWS Backup is smart enough to know to hold on to snapshots to fulfill the requirements or retention rules in the weekly and monthly backups, even if they've expired as far as the daily backup plan is concerned. I mentioned we'd talk about snapshot pricing. Whether you're managing snapshots individually or using AWS Backup, snapshot pricing is the same. The next slide points that out, but you're ultimately looking at about 5 cents per gigabyte. So if you're dealing with terabytes of data, that equates to about $50 per terabyte. And I already mentioned this, but EBS does not save empty blocks. So if you your initial snapshot will most likely be much smaller than your volume size. They'll save a full copy of the data to S3 for the first snapshot, but then for each incremental snapshot, only the changed part of the volume is saved. And you can learn more about that on the URL at the bottom of the slide, basically /EBS/pricing on the AWS page. You'll notice EBS Backup Pricing is the same price. There isn't a fee to use the AWS Backup service to manage your snapshotting. So you pay the same rate as if you're managing them without AWS Backup. And take a look at their pricing page to learn more about pricing for the various services that they can back up. But the pricing ranges from about 5 cents to about 10 cents per gigabyte, depending on the service. So just a little bit of a recap with EC2 backups. If your servers do not contain data, I'd recommend focusing on backing up your configuration instead so that you can rebuild those servers without necessarily restoring snapshots. I mean, ideally your constantly updating those servers and updating the images anyway, so trying to maintain snapshots of an old server state, in my mind, doesn't make sense if the server doesn't contain persistent data or user data. But if the servers contain databases, so let's say you haven't moved over to RDS yet, and you're still self-hosting database services on your EC2 virtual servers, you need to be aware of consistency issues. Let's say you have a very active database, a lot of write activity happening, and a snapshot takes place in the middle of a write. You could end up with a snapshot that is not consistent, meaning when you go to restore the snapshot and you start up your server, MySQL or whatever relational database you might be using will complain about the data. Sometimes it can fix the issue, sometimes it can't. We used a combination of methods for that, and I want to touch on it just for a moment because we're a MySQL shop, and we didn't drink the RDS Kool-Aid right away, so we were self-hosting MySQL. Our configuration consisted of a master server and then slave servers, which RDS would call read replicas, and we would snapshot probably one of the read replicas. I'd have to go back and look, but the important thing to know is we had to use a different file system that would allow us to freeze the file system and freeze MySQL. The sequence was exactly freeze the MySQL activity, freeze XFS, kick off the snapshot, record information in the snapshot details about where we were in the MySQL log, and then as soon as we get confirmation that that snapshot had kicked off, we would unfreeze XFS, and then we would unfreeze MySQL, and that worked out great. The combination of having those snapshots with the MySQL log information and then being able to restore a snapshot and then roll back the log from whatever point that snapshot was taken worked out really well for us. So that's certainly an option now that we're in RDS land and we're using backups there. Life is much easier. I'll talk about that here in a little bit. But as far as the recap goes on EC2, AWS Backup automates and retains your snapshots by policy. So rather than manually trying to manage that, you can tell it, I need to keep these snapshots for this amount of time, whether they be daily, weekly, or monthly snapshots. And then once you hit that time, they can expire. The other thing is AWS Backup can push those older snapshots into other storage classes, I believe, to help keep costs down. And then we talked briefly on using the snapshot lifecycle policy under the EC2 console if you're using other snapshot methods just to help keep your snapshots pruned. On to RDS backups. So a lot going on with RDS backups. Certainly RDS seems like it's going to cost you more when you at first glance, but in the long term, at least from our perspective, when we've switched from self-hosted MySQL to RDS hosted MySQL and then ultimately to Aurora, along the way we saw huge improvements in just administration and performance, especially with Aurora. But here's a diagram of what's happening with RDS backups. You can of course take manual snapshots. I'd suggest setting up automated backups for all of your RDS servers, and I'll talk more about why that can essentially be free for most people. But RDS backups leverage EBS snapshots just like we've been talking about with EC2 and store them in S3. RDS also stores your transaction logs to S3 pretty regularly so that you can perform a point-in-time recovery. And more importantly, when you're performing backups with within RDS, you don't see a performance penalty. At least with what we were doing, we were having to deal with freezing the file system and freezing MySQL and all of that, and they take care of all of that for you, and they insist that there isn't a performance penalty for using their backups. And then you can also push snapshots to other regions or share with other accounts, so that if something were to happen to a region or to your account, that data is not lost. Here's a view of the backup settings in RDS. So if you drill down to a database, there's really not much to it. They make it super simple. You have a drop-down menu that allows you to retain backups from 0 days, meaning you're essentially disabling backups, to about 35 days. You can schedule the backup window in universal time. In this particular case, with us being in Central Time, US time, these backups happen around midnight, and we give AWS about a half-hour window to kick off that backup. Now, RDS Snapshot Pricing is considerably higher. When we were talking about EC2 Snapshot Pricing, that was at 5 cents per gigabyte, or $50 per month for a terabyte of data. RDS snapshotting is almost twice that at 9.5 cents per gigabyte, or about $95 a month for a terabyte of data. But something to be aware of, Amazon does not charge you for backup storage up to the total database storage size for your region. So let's say you have 5 RDS instances, and each of those are allocated, I don't know, 10 gigabyte. That's essentially 50 gigabyte of database storage in that region. And they're saying that they're going to give you 50 gigabyte of snapshot storage for free. So with that being said, especially if you're on the original RDS and not on Aurora, you'll notice that you have to allocate space above and beyond what you're currently using. So you may have allocated 10 gigabyte per RDS database, but you may only be using 1, 2, 3 gigabyte at first. And so you even with incremental backups, if you're seeing a lot of data churn within your relational database, it would be unlikely that you would pay for backups unless you're nearing the capacity of your servers in the region. So if, say, you did have 50 gigabyte allocated across 5 different RDS databases, and you really were using nearly 50 gigabyte within them, it was highly transactional, a lot of the data was churning and being updated regularly, that would be a situation where I'd expect you to see some charges. But that's uncommon for most people. Most customers are going to have fairly static data, or their actual usage is going to be far enough below what they've allocated that, like AWS said, most customers will never pay for backup storage. But if you do hit that, just be aware that any additional backup storage would be billed at 9.5 cents per gigabyte. Now, so you'll see a common theme here. If you're using AWS Backup to perform RDS backups, so this slide looks nearly identical. Instead of being RDS Snapshot Pricing, this is RDS Backup Pricing, meaning backups through AWS Backup. Pricing is just the same. The rules still apply. You can have AWS Backup manage your backup policies for our RDS, but you're not going to pay additional fees for using AWS Backup. Some backup tips. I included part of this graphic so that we could talk a little bit about what's happening with RDS, but just as far as a RDS recap, I'd recommend setting up backups for all of your databases. There's really no reason not to, unless you have some sort of test database that's very high churn that would cause you to incur fees and that you don't need to pay because, in your opinion, you don't need to back up that particular database. So that would be understandable, but that's probably the exception to the rule. Another thing to be aware of, at least in our experience, restoring RDS backups is very slow. For anybody who's specifically with MySQL in our experience, for anyone who's worked with MySQL for a long time, you may have had an opportunity or the displeasure of restoring a MySQL dump to a database. And if it's a large database, you know that takes a long time. And essentially what's happening is, at least in native restorations, MySQL is importing all of that data and rebuilding the databases, and it just takes time to do that. I'm not sure if that's exactly what's happening when Amazon is restoring an RDS backup, but nonetheless, it's not fast. So if you have production databases, definitely have multiple RDS instances. If you have a read replica and your master server goes offline for some reason, you can fail over to that read replica, and then it becomes your master server. AWS will typically bring up a new server, and that will become the read replica, and over time it will have a copy of all of the data, and that happens in the background, completely managed where you don't have to mess with it. Versus if you only had one copy of an RDS database and that went offline for some reason and you needed to restore, just be aware that it can take a little while, especially with larger databases. That's where you can get into a jam. We talked about using AWS Backup with RDS to create a policy for backup creation and rotation that can be above and beyond what the RDS console provides. But then also, if a lot of these same rules apply with Aurora. That's been a great product for us. I don't go into Aurora specifics, but in the slides, but be aware that Aurora has some great capabilities in terms of snapshotting and restoring from point in time to a new database. So let's say you have a production database. This is one thing we especially liked about Aurora. We have large production databases that would take a long time to restore. So if we wanted to test new code in staging against production data, we would essentially restore from an RDS backup and perform our tests, but it took time. And with Aurora, we can clone either a backup or the current Aurora servers, the MySQL compatible servers, and the data becomes available in just the amount of time it takes to spin up those servers, because the new servers will point to the same data, but they essentially fork the data, and they're smart enough to know that any changes you make are only visible within the new servers. It's pretty amazing. Ping me if you'd like more info on that. But that's a little bit of an aside. If you need to perform offsite MySQL backups or any database backups, there are always tools for this, but specifically with MySQL, you can certainly run Percona or MySQL dump against your RDS servers or your Aurora servers. You could even, depending on which services you're using, if you're using RDS, you could potentially set up a MySQL slave or read replica in another cloud service, in another account, on site at your company. I don't believe that's an option with Aurora, so be aware that if you do move to Aurora, it limits your ability to sync offsite, but you do have some traditional options available. And since we're blazing through this, I'm going to talk a little bit about S3 backups. Like I mentioned when we opened, the Amazon infrastructure is designed to be pretty resilient to failure, fault tolerant, to where they aren't generally going to have issues keeping your data intact. But that's a different story when you start to talk about user error or any type of security incidents, or maybe even for internal company policies or regulatory reasons you need to have a copy of your data elsewhere. You've got a couple different options, and we'll run through those. I'm not going to go into these in detail, but I want you to be aware of them. With S3 buckets, you can set up cross site or cross region replication CRR or same region replication SRR. They are exactly what they sound like. You have a bucket in, say, US East 1 with same region replication. You could replicate the data to another bucket in US East 1. With cross-region replication, you could replicate that bucket to US East 2 or US West 2. And when you do that, just be aware that replicating to other regions is going to incur some transfer costs. So a benefit of keeping in the same region is that your costs would be lower, if any. But when you do that, the benefits are that it'll automate your copy process. So anytime new items appear in the bucket, they're automatically replicated to the other regions. And when that happens, it does preserve the metadata tied to each of those objects. So like in our case, anytime we're uploading objects, we'll generally gzip them and upload them, and then we'll attach metadata to indicate that they're gzipped content, even though we don't name them as such. And then any clients or browsers that we use are smart enough to know that that data is gzipped, and because of the metadata, it automatically handles that. So we get the benefit of smaller data sizes, but without the extra step in any of our software of having to unzip that. And I've been really impressed that the SDK handles that the way it does. It's a mini hack that we discovered on our own, so I don't know that it's officially supported, but we've used it a lot, and we would be in a little bit of a mess if we replicated and we weren't replicating those gzip headers because the file names aren't .gz. We also indicate the file type in our metadata because we'll store everything from text files and CSV and PDFs to other data files. And by doing that, if we serve up the data to clients, they're able to figure out what the data is and handle it appropriately. Another benefit of region replication is that you can isolate your data into multiple, or you can isolate accounts. And so let's say you have a central account that has very restricted access. You could replicate data into that account in the same or another region, so that even if something were to happen to your master bucket, you would still have your data. Now, a couple catches with this: if you set up replication, be aware that you do need to enable versioning on the bucket. Also be aware that replication only replicates things that are added after the replication begins. So if you have a bucket with 100 gigabyte of data files, it'll take a little bit of planning to set this up. You would essentially set up a new bucket in the same account alongside the existing bucket. You'd set up your remote bucket in either the same account or another account in the same region or another region. Yeah, you'd configure and test your replication to make sure that, yes, indeed, when I add a file to this, it is showing up on the other end. And then you would migrate your data to the new bucket. And while the data is being migrated, it is automatically replicated. But do be aware of that. If you set up replication, you need to plan for migrating data into that pair of replicated buckets. Or the best practice would be to just start off with that as part of your design. So as you're moving into S3, you have everything set up properly. Now, another possibility would be to replicate to another cloud or to on-prem. AWS has a few different options for on-prem, but let's assume that you're not replicating to AWS on-prem. You've got a few different options. There are various tools out there that you can use to sync data, but specifically I wanted to call out Google Cloud Storage. They have the ability to set and manage automatic daily transfers from AWS buckets to a Google Cloud Storage bucket. I'm not sure what their terminology is, but we've been using that for a long, long time, and it works great. I'll show you a screenshot in a second. We had looked at using Azure Cloud Storage, but couldn't find any native support for this type of synchronization. Now, granted, the Google Cloud synchronization is a daily transfer; it's not an ongoing, but for our purposes, that was perfect. Azure Cloud Storage would require some sort of third party, such as this GitHub project S3 to Blob, and it sounded pretty complicated to set up, so we passed on that one. But if you're in the Google Cloud and you log into the console, go to Google Cloud Storage, you can create a bucket on Google's end, and then you can create a transfer job, and they allow you to sync from another Google bucket, or in our case, from an Amazon S3 bucket. And they'll ask for the S3 bucket path, and they'll ask for an Amazon key pair. So you can go into IAM and set up a key pair that only allows access to the buckets you're wanting to move to sync to Google. Here's a list of transfers that had happened. Again, this was taken on the 3rd, so this was current as of then, but you can see that like clockwork, it performs the transfer every day, in this case at 11:27. And I'm looking at one bucket in particular. We're doing this with a bunch of different buckets, and I've been really pleased with how this works. Just be aware, if you're setting this up, that you make sure that you're receiving notifications if there are any transfer failures, or that you're monitoring that somehow. As far as S3 replication pricing goes, there are more moving parts. It's not as straightforward as EBS or RDS backups. So the main 3 price points that you want to watch out for are the transfer costs. So you're paying to transfer from one bucket in one region to another bucket in another region. The request costs. So let's say that initial replication, you're loading maybe 10 gig of data into a bucket, and that represents 1 million files. You'll have 1 million requests initiated by Amazon to perform that replication, and that would cost you about $10. And then your storage costs. And so assuming that you're replicating to a bucket and having the data classified as infrequent access, if you had a terabyte of data, you'd be looking at about $12.50 per month, and that's an ongoing fee. The transfer fees and the request fees are minimal after the initial sync. I mean, that just depends on your data churn in the bucket. If you have a lot of data changing, estimate those transfer and request fees accordingly, but your storage fee is really the only ongoing fee. There are some other minimal fees involved that we've seen, but we're talking pennies, so I didn't call those out specifically. Now, if you're backing up S3 to a remote provider, either another cloud or to some other systems that maybe you maintain on-prem, be aware that you're going to be paying internet transfer rates. So the 2 cents a gigabyte we just talked about, or $20 per terabyte, would be for in-region within AWS. The 9 cents per gigabyte is sort of the starting price for external transfers outside of AWS. And so that equates to about $90 per terabyte of data. Again, only something that you incur during the initial sync if you're using something like we found with Google Cloud. But you'll also pay for requests. You're going to have read requests, which are minimal. The requests that we were looking at on the prior page were write requests or put requests, and they cost a little bit more. So the read, in the whole scheme of things, once you get over that initial sync, your costs really just come down to whatever you're paying for storage on the remote side, whether it be Google or some on-prem server that you have. But the most important takeaway from this is to be sure you're using some sort of incremental backup method. Don't scan all of your files. You want to download them once and then just download any changes from them then on them out, so that you're not paying over and over and over to transfer 100 gigabyte or a terabyte of data. I mean, once it's one and done, once you've backed it up, there's no reason to keep copying it. Recap on the S3 side of things, a couple tips to take away from this talk would be what I pointed out. If you're using AWS replication, be aware that that will only replicate new items after you've set up replication. So we talked about creating a new source and destination bucket, setting up replication, and then copying all of the items into that source bucket. If you're using some sort of on-prem or intercloud backup to archive S3 data to another provider, just be aware that you're going to incur internet transfer fees. But if you use an incremental transfer method, you can keep your costs down. And with that, this is normally an interactive presentation at Dev Night in Springfield, Missouri. Was going to ask what some of the other folks are using to back up their EC2 instances or RDS instances or S3. So if you're watching this online and you have something that you're very pleased with, I'd love to have you share that in the comments. And if you have questions, again, feel free to leave a message in the comments or ping me on Twitter at JasonK. Thank you very much for watching.